In this video, we are looking at the Indianapolis weather data. This is part 2. So if you haven't looked at the weather data part 1, you should go and check out that video. The data that we're looking at is this data here from the Indianapolis airport from 1950 to 2018. We've got precipitation, snow depth, max temperature, min temperature, mean temperature for those dates. And we already have something to start with from the last video that we can give it a year, and it goes through all the dates in that year and adds up the mean temperature. Okay, so we have a function to load the data given a file name, and it returns a dictionary. So there's a dictionary here with the data. Each item in the dictionary has a date and each of the other items. Okay, so first we load the data and then we can do different things with it. So here we loop through the data. This D is going to be one of these. Okay, so we can look at the date to look for a particular year that they typed in. All right, that's how it works right there, right now. Okay, so I'm going to add a few things that we can do here, and I'm going to make functions out of these. So this year average, I'm going to put into a function. So we'll look at year average given the weather data and given a particular year. And I'm going to print out. So all of this is going to be part of the year average function. Okay, so what I'm setting this up to do is we want to have some functions to do specific items, and then we'll call those functions. So the way our code looks here, we've got a function defined that can load the weather data. We've got one that can compute a year average, and then we call those. Okay, so if I get the year here, then I want to do year average with this data and with this year. And right now that should do the same as it did before. Okay, so now why don't we go ahead and do not just the temperature, but the precipitation. So here was the temperature. I'm going to do the precipitation as well. So any date that's in that year, I'm going to add on to the precipitation total. So W data and percip. If I'm going to print more than one thing, then I'll have here mean temp, like that. And we'll print the total precipitation. Okay, so we've got both of those. If I want to look at a range of years, then I would be doing this over a range. So let's say that I wanted to look at the 1950 up to 2018. So there's different ways to do that. Well, for now, let's just make a new function. And we're going to do something similar to the year average. So I'm going to take that as a starting point. So let's say we're going to do why don't we modify the year function? So we're going to let it take two different years. So years, it's going to have a start and an end. And I'll call this year start and year end, starting from and ending, and I want to have these line up when they print. Okay. Right, all of our years are going to be 4 digits. So let's just run it like this first. So right now I'm sending in 2 different years, and this code, let's put it like that. So you could pause, and if I run this and type 1990 to 2000, what do you think it's going to print? We're not done yet. So you could pause, and what do you think it's going to do? Okay, right now it's really just using this start year. It's not using the start or the end. It's not using the end. So I'm going to need to look at both of those. And I want to convert them to integers to make sure that I'm comparing them the way I want to. Okay, so I'm going to say this is integer version. Okay, so that I can compare. And then this D0 bracket 4, that was from the date. So when we read in the data originally, data bracket 0, this was from the CSV file. So in the CSV file, the first field is the date. We get that as a string. In the code, that was this data bracket 0 when we read it in. And that was the key or the index for looking up in the weather data. If I do a loop through the weather data, it's a dictionary. And if I just printed D here, it would print all of these because those are what I used as the keys or the index in that dictionary. So the first 4 digits is the year. So I'll say year is D0:4 and convert that to an integer. Okay, so now if I do this, it should do just what it did before, unless I have mistakes, except now the year and the start and the end are integers. Okay. Now, if I want to keep track for multiple years, then instead of just one number here, I want to have a dictionary. So the temperature total for each year and the num days total for each year and the precipitation total for each year. There's different ways we can do that. We'll do one of them here. I'm going to make these all empty dictionaries. And then for each year in the range from start to end, temp total year is 0. All of these are going to be 0. So we initialize all of those. So these are counts or totals. All right, so then inside of here, we've got the year. We want to check to see if the year is in the range that we're interested in. So now instead of this, we're going to have years at least start and years at most end. Then the temp total is for a particular year. The precipitation total is for a particular year. And the num days is for a particular year. Then if I go down here, I'm going to not print this one because it won't work. But let's just print the precipitation total and see what happens. If it works. Okay, so the precipitation total there, it's a dictionary. And we set it up so that the precipitation total has each year from the start up through the end. And we can see these totals here. And if I printed the temp total or the num days, it would be the same. So we'll print the num days as well. Here's the num days, and we should see a leap year, 1992, 1996, and 2000 was a leap year as well. All right, so I want to print each year on its own. So this here, just to leave a comment for what we were doing. For each line in the weather data, check if in this range of years, and add to counts or totals. Okay, so then at the end, for each year in the range, print off total or average. And each year in the range was for year in range start to end plus 1. So I'm going to print year and then let's see, here I'm going to print the order that I'm going to go. So the year, and then we had the temperature average, the precipitation total. Those are the things I'm going to print. Okay, so we had the year is year. The temperature was temp total over num days, but we had each of those per year. And then the precipitation was per year. And just for fun, we'll print the number of days as well. as the second item. That's a sanity check because we know what that should be. Okay, so we've got a year, we've got a number of days, temperature, and precipitation. And if we want these to line up, we can try doing tabs in between to make them line up better. The precipitation there doesn't, so let's see if we can make these numbers print just with maybe one decimal place. Okay, different ways to do the printing only in a few decimal places. We'll go with round. There's a function called round. And let's just check that out first. Okay, so that's how round works. If we want to say 2 or maybe 1 decimal place will probably be enough. So I have a number, and I'm going to do it to 1 decimal place. Same thing for the precipitation. There are other ways to do this printing, but we'll go with this one for now. Okay, now that looks nice, and let's take a look at what the data looks like for the whole date range. Okay, so temperature. See if you notice an obvious pattern. It seems to be, so it kind of looks like the temperatures are higher in the 90s into the 2000s, but not every single year. So we'd have to look at this on a graph, which we could do. So we could save this. Let's say I'm going to save this. Well, so you could save this into Excel or whatever other program you want to use to graph, and then plot the temperature to see what it looks like. Does it look like it's sort of going up or not? Okay, so there we have looking at things for averages for a year. Why don't we go ahead and put, well, let's describe what we would need to do to put snow in. Let's say we wanted to do a total for snow. Well, snow is like precipitation, where we'd just be adding it up. So anywhere you see precipitation, we would want to do something similar, copy paste, and change that to snow throughout. But then inside of this code here, we have to know what did we call the snow field in that dictionary. And that was this. So we'd have to use that. If we wanted to look at the snow depth, we could use that. Okay. All right. I want to put in a new type of function here. I'm going to comment this, and we'll come back to that potentially. But I would like to do another type of data here. So I want to look at a day average. So I want to look at a day of the year to compute average. And I'll do it with the same format as used here. So this is month and day. So I want them to type it in like this. And I want to have a function that's something like this year's average. So I'm going to give it wdata and day average. So let's just make sure that I'm going to be inputting that correctly. Something like that. All right, I don't have a function called day average. That's what that error is. So let's go ahead and put that in. So question for you. I'm calling day average like this. So how do I have to declare it up here? I need to take two parameters. One is the dictionary with all of the data, and this is my date string. So I can call it whatever I want here. I'll call it date string. Okay, and my overall structure is going to be similar to this year's average, where at some point I'm going to loop through all of the weather data, and I only want to look at ones that match my date string. So I want to pull out the date string inside of this particular date. Remember that the keys or the indexes in the weather dictionary are date strings that will look like this. These are strings, so if I want to pull out these, which indexes would that be inside of this string? So I've got 0, 1, 2, 3, 4, and then I'm going to start at 5. And to the end. So that would be this here, and then I want to check if that matches the date string I'm looking for. If it is, then I want to look at the averages for that date. So I'm going to look at the total number of days again, and mean temperature. I'll add up all the mean temperatures and divide. So if I find a match in here, I'm going to do num days plus equal 1, mean total plus equal w data. Well, let's go back up and see what we did here. W data bracket D, actually this thing here. And we'll print that out. So we're going to have, and we'll go ahead and round the mean total divided by the number of days, and we'll round it to 1. So now 01-01, January 1st. The average temperature over the whole time period, 29.1 degrees Fahrenheit. Let's try 07-01, July 1st, 74.8. That seems reasonable. All right, now what if we want to do the high temperature and the low temperature. Right now I'm doing the mean. What do I need to change? So look at the code and think about what we need to add to also do the high temperature and low temperature. Okay, let's see. So we need to look at what those are called in the actual data. So in the data, we've saved, we were just looking at mean. We've also got Tmax and Tmin. So let's go ahead and do the same thing for Tmax and Tmin. And we probably want to print out again what order we're printing them. So I'm going to do this. This is mean, Tmax, Tmin. And I'll separate them by tabs again to try and make it look nice. And let's go ahead and print out the number of days as well. So that's how many data points we had here, which should be just the number of dates, the number of years in our range if we're looking at a particular day. January 1st. How many January 1sts were there? So we see there's 69 years. Let's put the separator in there. Okay, so there we see that. Okay, this is long enough. So we could already kind of try and experimentally see what's the coldest day of the year. So January 30th is colder than January 15th on average in this range of years. How about February 15th? So 02, that's warmer. So it would be nice to go ahead and do all dates to see what the average is on all the dates, but we'll leave that for later. Okay, so what you want to do is you want to, I'm going to hold the screen here, and you might want to look back at the code that we just wrote. So you could pause. And now down here, you could pause again on the day average function. And how we're calling this. And up above, this is how we're reading in the data, which we did in the first video. Okay, that's it for now.